So now we're going to discuss onto functions. And so what it means for a function to be onto, or a surjection, is if and only if for every element b belonging to b, okay, so we've got this function a to b, there is an element a belonging to a with f of a equal to b. So what this is basically meaning is that if I take everything in the codomain, so again, just like one-to-one, we're going to kind of look at the codomain. I'm going to take everything in the codomain, okay? And I'm going to take every element, and if there's something in A that maps to B, right, over F, then what I have is I have an onto function. It's basically like saying that I can get everywhere in my codomain, all right? So let's take a look at an example, see if this might kind of like illuminate things for us. So let's take, for example, we'll take the example that we had before, f of x equal to 3x plus 1, okay? And we know that f, we're going to take that from R into R. Okay, so we've got R, that's our domain, and then we have R, our codomain, and then we'll have our function f. And so what I want to imagine is okay, I've got this question of like 1, okay, the number 1, it's going to end up, where's it going to map back to, right? Okay, and so 1 is going to end up mapping back to 0. Yes, because 3x plus 1 equal to 1 means that 3x equals 0, and so x will equal 0. Okay, that's basically it. So I've taken an element, I've set something equal to f of x equal to 1, right? Okay, and I found that it actually, in fact, maps back to 0. Or let's take, for example, we'll choose 7. So I take 3x plus 7, 3x plus 1 equals 7, right? So that's my value of f of x. And so 3x equals 6, and so x equals 2, right? And so consequently 7 will map back to 2, right? And you can kind of imagine the idea here is that if I take anything in R, right? And you can pick one, pick anything in R, that I will then be able to find an x over in R that will map to that number, okay? So we're picking stuff in the codomain, right? We're asking a question about the codomain. We're asking the question is, really the question is the range, okay, all of the sets of all of the images of A, is the range actually equal to the codomain, right? Which is in fact, inside of linear algebra, that's how we prove that in fact we have an onto function. So we're like, okay, well, is the range the entirety of the codomain? And in the case of 3x plus 1, it is in fact. And we'll look at how to prove that in just a little bit. Okay, this is a an onto function. Now let's take a look at another example. We'll look at that other example that we had been looking at. Okay, and we've got f of x equals x squared, right? And we're going to let f go from R into R. And we've got R as our codomain, and then we'll create this mapping f, okay, which is x squared. And I do know that if I have, let's say, for example, if I've got 4 here, that's going to go to 2, and that, in fact, is going to go to negative 2. So there is an image of 2 and negative 2, right, inside of the codomain. So this element of the codomain does work. But we also know that our range isn't, in fact, all of R. Say, for example, I take negative 1. If I take negative 1, well, x squared equals negative 1. That means that x equals plus or minus the square root of negative 1, which is equal to plus or minus I. The problem with that is that I does not belong to R. Okay, so there's nothing that negative 1 maps back to. So this value has no preimage in R. So it has no preimage in R, and so consequently, f of x equals x squared when going from R to R is in fact not onto. F, right, R to R is not onto. Now here's the thing. We can restrict our domain, okay? So I'm going to give an example number 3. And in example number 3, I'm going to take f, and I'm now going to go from R to R plus 0, okay? So what I'm going to be looking at is all the positive real numbers in addition to 0, okay? And so I'm going to define f as being f of x equals x squared. So now I have r, and now I have r over here, and I'm going to go into f, use f, okay? Now, here's the thing, this is r plus 0. So there are no negative numbers are in my codomain. So there are no negative numbers in my codomain, so consequently, hey, awesome. What that means is that I don't have the problem that I had in the previous example. There's no -1 in here. There's no -5. There's no negative anything. These are only positive numbers, right? And like 0. So like 0 maps to 0. 4, right, will map to 2 and -2. No problem, right? Okay. We're going to get all the values in R are going to map to something in R plus the positive or the non-negative values of in the real numbers. And so consequently, this function with this codomain is onto. So that's really important that what we're looking at, we want to be very careful as to what's being defined as our codomain. All right. In the previous example, it was all of R, not onto. In this case, it's all the non-negative values of R, and so consequently the function is in fact onto. Okay? So that's kind of the idea. Do our values in the domain map onto the entirety of the codomain? Is the range actually equal to the entire codomain? Right? And that's what it means to be onto. And that completes this discussion.